Hello everyone, today we are going to talk about this humerus. The surfaces of humerus. Where the olecranon fossa is present, this is the posterior surface. Where coronoid fossa is present, this is the anterior surface. Where tuberosity is present, this is the lateral surface. And this quite broad region is medial surface. Okay, talking about the tuberosities, these are the proximal extremity, distal extremity. This is the groove present here, musculospiral groove on the lateral side. Here deltoideus tuberosity is present. It will give the attachment to deltoideus muscle and brachiocephalicus as well as anterior major muscle. Clear? So on the medial side, here a surface is present. This is teres tubercle, which give attachment to latissimus dorsi and teres major muscle tendons. So this tubercle is for the insertion of teres major and tendons of latissimus dorsi. So medial condyle is larger than the lateral condyle, but talking about the epicondyles. So in the epicondyles, which one is larger? Lateral one. Clear? So lateral epicondyle is quite larger than the medial epicondyle. Now this coronoid process, this coronoid fossa, this give attachment to coronoid process of radius, and this olecranon fossa give attachment to Anconius process of the ulna. From this coronoid process, extensor muscles, basically extensor carpi radialis and common digital muscle will arise from this medial epicondyle. I talk about coronoid fossa from the lateral epicondyles. From the lateral epicondyle, which muscle will be coming? Ulnaris lateralis. And from the medial epicondyles, flexor carpi radialis, pronator teres, flexor carpi ulnaris, superficial digital flexor, and humeral head of deep digital flexors will be coming. And keep in mind that the ulnaris lateralis arising from the lateral side of lateral epicondyle is a flexor, but it behaves as an extensor. So to summarize, basically the muscles on this anterior lateral surface are extensors and the muscles on the medial surface are basically the flexors. So is this something left? Okay, talking about the proximal extremity, this is the head. So this will be the total, this is the lateral tuberosity and this is the medial tuberosity. This smaller one is medial tuberosity, this complete is the lateral tuberosity. They are separated by this bicipital groove where brachialis, tendons of biceps brachialis muscles come. And on the lateral tuberosity, the bigger part is summit and the posterior part is convexity. This summit overhangs this bicipital groove. It gives attachment to lateral head of infraspinatus muscle because this is basically on the lateral side. So you can see this summit and this rough surface and this circular surface. Basically here the lateral head of infraspinatus muscle will attach, and on this convexity, like here part, the medial tendon of the infraspinatus muscle will be attaching. Talking about the medial tuberosity, it is smaller basically as compared to lateral tuberosity. Its anterior and posterior surface is there. Okay, and anterior part give attachment to supraspinatus muscle and deep pectoral muscle. Posterior give attachment to the subscapularis muscle. The head is present on posterior medial aspect. This is circular, this is neck which connects head with the shaft. It is a constricted part. Clear? So I think, and more things you need to learn. The posterior surface is round and smooth. The lateral surface is spirally present. The anterior surface is basically somewhat triangular, and the medial surface is plain downwards and rough above side. Clear? On the anterior surface, this groove, this present deltoideus tuberosity, which given we have discussed also insertion of deltoideus muscle, teres major and brachiocephalicus muscle. But this musculospiral groove, it gives attachment to brachialis muscles and radial nerve. And on the medial surface, if we talk about, this is the teres tubercle. So humerus is located like backwards, downwards and backwards. It is having a shaft. We have discussed the four surfaces of a shaft. right? There's a extremities proximal and distal one. This was the fastest revision of humerus we can do.